Hello everybody, welcome to Mr. Morrow's Algebra class. We're going to be learning today about Lesson 1-2, Properties of Real Numbers. Let's go ahead and just go over the definitions here. It's pretty simple, and it's very important for you to be able to know these definitions to be able to master mathematics. A real number is any rational number and or irrational number. No imaginary numbers. Imaginary numbers are something we're going to talk about later on, but a real number basically is any rational or irrational number. So as far as we are concerned, it's any number. Now, a rational number is any number that can be written in a over b or in fraction form. Rational numbers include natural numbers, whole numbers, integers, repeating decimals, and terminating decimals. Now, as far as repeating and terminating decimals go, repeating decimals would be something such as 0.3 repeating or 0.53 repeating. That's a repeating decimal. A terminating decimal is a decimal that ends. It is finite. So in other words, we're looking at something like 0.625. It ends. Or 0.7, it ends. Or 0.0263, it ends. It terminates. So again, rational numbers include natural numbers, whole numbers, integers, terminating decimals, repeating decimals. Okay, now, natural numbers. Natural numbers are part of rational numbers, but let's go ahead and explain that. Natural numbers, or counting numbers, are whole values not including 0. So they would include numbers such as 1, 2, 3, 4, 5, etc., but not including 0. Whole numbers. Whole numbers are the natural numbers including 0 this time. So this time 0 is included. Whole numbers would be 0, 1, 2, 3, 4, 5. Natural numbers and whole numbers do not have decimals or fractions. Integers. Integers are the whole numbers and their opposites. So whole numbers and their opposites include 0, 1, negative 1, 2, negative 2, 3, negative 3, etc. Integers, as well as natural numbers and whole numbers, do not include decimals or fractions. Only rational numbers include decimals and fractions. And the last number category is irrational numbers. Irrational numbers are numbers that cannot be written in a over b or fraction form. They include non-perfect squares, such as the square root of 5, and they also include non-repeating and non-terminating decimals. So these are decimals that never repeat and never terminate. For example, pi. Pi is an irrational number. Or if I were to give you 0.3625378 ... it just keeps going forever. There's no particular pattern, nothing is repeating, and it never terminates. Okay, now let's look at an example. Your school is sponsoring a charity race. Which set of numbers best describes the number of people P who participate in the race? Since there has to be at least one person, the answer would be natural numbers. You can't have 0 people, so it can't be whole numbers. Example 2. In example 1, if each participant made a donation, D, of $15.50 to a local charity, which subset of real numbers best describes the amount of money raised? Well, since the total donation will be most likely have a decimal, the answer would be rational numbers. Because again, rational numbers include decimals. Okay, now let's talk about some inverses. The opposite, or the additive inverse of any number a is negative a. And the sum of a number and its opposite is going to be 0. That is called the additive inverse. So for example, when I have 12 plus a negative 12, the additive inverse of 12, the sum will be 0. Negative 7 plus the additive inverse of negative 7, which is positive 7, will equal 0. Now, we can also look at it as a reciprocal or the multiplicative inverse. That's another type of inverse we're going to work with. And the multiplicative inverse of any non-zero number a is 1 over a. And the product of the number and its reciprocal is going to be 1. This is called the multiplicative identity. So in other words, 8 times the multiplicative inverse of 1/8 is going to equal 1. And negative 5 times the multiplicative inverse of negative 5, which is negative 1/5, is also going to equal 1. Now, properties of real numbers. You've probably learned these a lot of times, many times through your middle school years. You really need to understand what they are, so we're going to go over them very carefully. The commutative property of both addition and multiplication. The commutative property basically states you can switch the order of an addition or a multiplication problem without changing the answer. So for example, 2 plus 3 equals 5, but 3 plus 2 also equals 5. That's a commutative property. 2 times 3 equals 6, but 3 times 2 also equals 6. So you can change the order of a multiplication or an addition problem, and that is called the commutative property. You then have the associative property of both addition and multiplication as well. And the associative property of addition and multiplication are very similar to the commutative property, except they deal with parentheses. Now, that does not mean that every time you see a parenthesis, you are going to have an associative property activated. No. In order for you to activate the associative property, look at what happens here. See, you have 2 outside of the parentheses, and then you have 3 plus 4 inside of the parentheses. But then that equals 2 plus 3 inside of the parentheses plus 4 outside of the parentheses. Since I pulled a 4 out of the parentheses, that activates the associative property. So in order for you to activate the associative property, once again, one of the numbers inside of the parentheses has to be pulled out, and one of the numbers outside of the parentheses has to be put inside of the parentheses. Same thing happens with multiplication. In this particular case, you have 2 being multiplied on the outside and 3 times 4 on the inside of the parentheses. It equals 2 times 3 inside of the parentheses, so that means the 2 was placed inside of the parentheses, times a 4 outside, so that means that the 4 was taken out of the parentheses. A lot of times kids are tricked with situations such as 2 plus 3 plus 4 equals 2 plus 4 plus 3. Well, in this case, if you really look at it, did I take anything out of the parentheses? No. All I did was switch the 3 and the 4. But the 3 and the 4 are still inside of the parentheses. So this would be an example of the commutative property, not the associative. For you to have an associative property, once again, please remember, you have to take something out of the parentheses. You're taking it out of the parentheses. Okay, the distributive property. The distributive property involves multiplication. And basically what's happening is that the outside number that is being multiplied to everything inside of the parentheses. So a times parentheses b plus c is going to equal a times b plus a times c. Mathematically speaking, we'd be looking at 2 times parentheses 3 plus 4. Well, 2 times 3 is 6, plus 2 times 4 is 8, and that would be 14. The additive identity property. The additive identity property, think about the word identity. Okay, your identity is yourself. When you look at yourself in the mirror, you're looking at your identity. So A plus 0 is A. In other words, anything plus 0 is itself. That's the additive identity property. The multiplicative identity property is similar, but it's anything times 1 is equal to itself. So A times 1 equals A. That's the multiplicative identity property. So the additive identity property, 3 plus 0 is 3, because anything plus 0 is itself. And the multiplicative identity property, 3 times 1 is 3, because anything times 1 is itself. The additive inverse property. Inverse, think of opposite, okay? In order for the additive inverse property to work, you have to add something to the original number that is going to cancel it out and make it 0. So in other words, A plus a negative A is going to equal 0, because A plus negative A, they cancel out at 0. 3 minus 3, or 3 plus a negative 3 is 0. The multiplicative inverse property, again, we're looking at inverse. Think of opposites, okay? A times 1 over A equals 1. When you have a multiplicative inverse, the product of the original number and its inverse is going to equal 1. Please remember, though, A can never be 0, because you cannot have a 0 in the denominator. That's called undefined. It doesn't exist. It's impossible. So 3 times 1/3 equals 1. But also, please remember, if I had 5/6, okay, the multiplicative inverse of that's going to be 6 over 5, which is also going to equal 1. The zero property, multiplication, basically states that anything times 0 is 0. A times 0 is 0. 5 times 0 is 0. Anything times 0 is 0. Now, closure property of addition. I just want to go over this. It's pretty simple, but closure basically means that when you're adding two real numbers, you're going to get a real number answer. So A plus B is a real number. 18 plus 12 is also a real number because it equals 30. Same thing with multiplication. Closure property of multiplication. AB or A parentheses B or parentheses A, close parentheses, open parentheses, B, close parentheses. That all means A times B, A being multiplied times B. When two real numbers are multiplied, the answer is also going to be a real number. 8 times 3 is 24. Okay, last example. Which property does the equation illustrate? Well, if I'm looking at negative 2/3 times negative 3/2, the product's going to be 1. We're talking about inverse property of multiplication. We got 3 times 4 in the parentheses times 5 equals 4 times 3 in the parentheses times 5. I did not take anything out of the parentheses. So actually, this is not associative property at all. I was wrong. I apologize about that. That is commutative property. I caught a little mistake there. I apologize. And again, the reason it is not associative is because nothing was taken out of the parentheses. In order for this to have been associative, it would have been written in this fashion. See, if I did it this way in red, that would be the associative. Why? What's the difference? Well, in the red example here, I have 3 times 4 in the parentheses, but then I have 5 times 3 on the other side of the parentheses. So that means that I took the 4 out and I put the 5 in. That's associative. Okay, I have 3 times parentheses G plus H plus 26 equals 3G plus 3H plus 26. Well, what's going on there? Well, I had to multiply the 3 to the G and to the H. So I used the distributive property. Okay, let's use the properties of real numbers to show that A plus 3 plus a negative A equals 3. All right, let's justify this step by step. If I have A plus 3 plus negative a. Okay? That equals a plus parentheses negative a plus 3. What I did there is I just simply switched the order of the 3 and the negative a. So I used the commutative property of addition. Then I went ahead and combined a plus a negative a plus 3. I combined it all in one parenthesis. So that means that I put something inside of the parentheses. And remember, whenever I put stuff inside of the parentheses or take stuff out of the parentheses, I'm talking about the associative property of addition in this particular case. Then a plus negative a equals 0. That's the inverse identity of addition. And then, of course, 0 plus 3 is 3. And I guess technically that would be the closure property, because 0 plus 3 equals 3, and that is a real number. I hope you guys have learned a lot about the properties of numbers and the classifications of them. Thank you very much, and have a great day.